Good morning everyone, and what we're going to be moving on to today is looking at problem solving in trigonometry, specifically looking at problem solving to do with 3D shapes. So this is a nice little flowchart that can help us try to figure out which formula we need to use in trig to help us solve a problem. So the first question I always ask myself is it a right angled triangle? And if yes, it is a right angled triangle, then our toolbox consists of SOHCAHTOA, or sine, cos and tan ratios, or Pythagoras, c squared is equal to a squared plus b squared. If it's not a right angle triangle, then our key toolkit is involving the sine rule, the cosine rule, and the area of a triangle formula. So my sine rule, my cosine rule, and my area of a triangle formula, which are the new formulas that we have done this year. So what I would do now is pause this video, find a blank page in your notes and add this flowchart in to help you with your problem solving skills. Then when you're ready, we're going to go and we're going to look at example 1 in solving problems in 3 dimensions. Now the key thing here is when we're solving problems in 3 dimensions, we try to solve them by breaking down the 3D shapes into their 2D shapes. So if we look at this question here, it says the given figure shows a cube of side 5 centimeters. So I know that a cube has all sides the same. So every side on this cube is going to be 5 centimeters. Find the measure of the angle between the diagonal AD and the base of the cube. So that's marked here by theta. So I can see that right now. If I take out the main triangle that's in, I have a right angled triangle. So I can see that I have theta here, I have AH on this side, which is the height of the cube, which actually I can see has to be 5 centimeters. I have the base HD, which I don't know, and I have the diagonal AD, which I don't know. But what I can see here is that base HD, I can find using Pythagoras at the bottom. Because if this is a cube, this has to be a right angle triangle, split by the diagonal going through. So I have HD, which is going to be my base in the next triangle, HE, which I can see is 5 centimeters, ED, which I can see is 5 centimeters, and we're going to use Pythagoras to find this guy. So I have c squared is equal to a squared plus b squared. I have x squared is equal to 5 squared plus 5 squared. So I have x squared is equal to 25 plus 25. So I have x squared is equal to 50. So my next step is I square root both sides to find x here. So onto your calculator now we're going to put in the square root of 50, which gives me 5 root 2. So I can see x now is equal to 5 root 2 centimeters, which means that HD is equal to 5 root 2 centimeters. So I can add that in now over here, where I have HD is equal to 5 root 2. I can see now I have 2 sides of the triangle, so I can use SOHCAHTOA to find that missing angle. Where I have O and A, so I'm going to need to use tan. So I have tan of theta is equal to O over A. Tan of theta is equal to 5 over 5 root 2. My 5 and my 5 cancel, so I get tan of theta is equal to 1 over root 2. To find theta now I need to bring tan across, so I have theta is equal to tan inverse of 1 over root 2, which I can now put into my calculator, again making sure that your calculator is set in degrees mode. And tan inverse of 1 over root 2 gives me 35.26 degrees, which is my final answer here because that's what they wanted, was this angle here. So it's all about, again guys, finding our 2D shapes in the 3D shapes. When I pulled out this triangle, I saw that I would need an extra side to be able to find this angle. So that's why I went looking for HD. HD, I could see I could pull out this triangle and use a nice and simple Pythagoras' theorem. Then I could use a nice and simple tan because both of my triangles were right angle triangles. So what we should do now guys is pause this video here, add this into our notes copies, and then look back over the example and our flowchart to look at the problem solving in Trig. Thanks guys, bye now.